This is Algebra 2 with Trig, section 6.6. We're solving radical equations. Equations with radicals that have variables in their radicands are called radical equations. Here's an example. We have a cubed root, so that's a type of radical. The variable is inside the radical, called the radicand, and it's an equation because this radical equals a certain number. To solve, we're going to isolate the radical on one side of the equation. That's if necessary. In a lot of cases, the radical is already by itself on one side. Sometimes you have to subtract or add something, divide something away so that you can get it just to be the only item on one side of the equal sign. We're going to raise each side of the equation to the same power to eliminate the radical. Sometimes it's a fractional exponent is the way that we can get rid of it. Sometimes we'll be working specifically with the radical and we'll cube both sides in a case like that. Then we'll solve the polynomial equation. And then it's always a good idea to check your solutions. There'll be some situations where you'll get an extraneous solution, which is a solution that mathematically worked out, but mathematically it can't be an answer. And we'll talk about that when we get there. So here we have our first example. It's an equation. It has a radical, so it's a radical equation. It's specifically a square root. So we're going to square both sides. When you square a square root, you get what's inside. Now you have a basic algebra equation that you can solve by adding 9 to both sides. And dividing by 5. And then to check that, we would take the 26, plug the 26 back in, and 11 is what we started with. So yes, of course that works. Okay, here's our second example. We're looking at the cubed root of x. Then we minus 9 from that. We're looking to see where or when that would equal negative 1. Now remember, the first step talked about isolating the radical. Well, the radical is not all by itself. So the first thing we need to do is add 9 to get the radical by itself. And then we're going to cube both sides. When you cube a cubed root, you get what's inside. 8 times 8 is 64, times 8 is 512. And then we can check that by saying the cubed root of 512, and we minus 9. Well, the cubed root of that is 8, which is negative 1, which is what we started with, so that checks. What do you think we do to start out example number 3? We'll have to divide by 2. You definitely can't distribute it in. You don't subtract it. you have to divide it. Then we raise the power by 3 to get rid of a cube root. So you get what's inside. 2 times 2 is 4 times 2 is 8. So we get an answer of 11. We can check that. So we get 2 times the cube root of 8. So the cube root of 8 is 2, and that gives us 4, and 4 is the value that we had on this side. So that checked out just fine. Here we're looking to see, remember the first step is to isolate the radical. When we look at this, the radical is already by itself. So we're going to square both sides. And when we square both sides, you get what's inside. Negative 8 times negative 8 is 64. And in this case, we would get 55. X equals 55. Now when we go to check that, notice what happens. X plus 9, so 55 plus 9, that is 64. And the cube root of 64, just the cube root, is 8. But we wanted to know when it was negative 8. So that did not match. So this is not a solution. So we could call this extraneous solution. We did all the math 100% correctly, but when we went to test it, we got a solution that did not make the original equation true. Now, there's a hint about this one. If you look up here in the very beginning, when you're taking the square root of something, you know that when you take the square root of something, you have to get a positive answer. They're saying here that when you take the square root of something, you're going to get a negative answer. Of course, that's impossible. You can't take the square root of something to get something negative. Only if you were taking the square root of both sides would you deal with a plus or minus. It's not a plus or minus situation here, so you would expect something to be positive. With example number 5, if an 8-foot ladder is leaned against a wall, the height of the ladder along the wall is given by this equation, where x is the distance along the floor from the base of the ladder to the wall. Estimate the distance that the ladder should be placed from the wall in order for the ladder to reach 7 feet off the floor. So we have the height of our ladder, the height of the wall. We know that the ladder itself is 8 feet. What we're trying to figure out, the distance that the ladder should be placed from the wall. What's the distance it should be placed? So the height of the ladder along the wall (64 minus x squared), the square root of 64 minus x squared. We want the ladder to be 7 feet up from that. how far away from the wall would it be? What would x need to be? So we would square both sides. So in this case, there's when you take the square root and you're squaring it, you get what's inside. So now you have a negative, so if we divide by a negative to both sides, we're going to get a positive. And then if you take the square root of both sides, you get plus or minus the square root of 15. This would be an example where plus or minus will come into play. But of course, this is geometry. We're not looking for negative answers. So this is, with your calculator, approximately 3.87. On the second page, when an equation contains a power with a radical exponent, you can solve the equation using a procedure similar to the one we did with radical equations. In these cases, isolate the power and then raise each side of the equation by the reciprocal of the rational exponent. So here we have 7 times x to the 3/5 power. Well, the 3/5 is only affecting the x. So if you were going to write it as a radical with an index of 5 and to the 3rd power, the 7 would be on the outside. It is not part of the 3/5. So in other words, we can divide that away. Now, to get rid of the 3/5, we need to raise this to a power that's going to get rid of 3/5. An easy way to do that is to look at what's going to make it the same number over itself. So 15 over 15, which is a value of 1. When you multiply these, because you're raising a power to the power, you get x to the 1st power. And here we're taking 8 to the 5/3. Well, the thirds means that it's a cube root. And we can put the 5 on the outside. Well, the cube root of 8 is 2 to the 5th power. So we know that that's going to become 32. And we can check that. 7 times 32 to the 3/5 equals 56. Well, the 5th root of 32 is 2, and then 2 cubed is 8. Does that equal 56 is the question, and then yes, 56 equals 56. Works out just fine. On this side, you can't add the 4 across because this isn't really a 4. This 4 is being affected by the 2/3 exponent. So it's already isolated. So we're going to raise it to the power of what? Three halves. So here you get 6 over 6, which is x minus 4. And on this side, this is the square root of 16 cubed. The square root is 4, and 4 cubed is 64. Then we add 4 to both sides. We get 68. So now we can check this one. So we're going to plug the 68 in for the x, which gives us 64. The 3 tells us we're going to take the cubed root of this, which would be 4, and the 2 tells us that we're going to square this. So 4 squared is going to become 16. And 16 is what that equals. So that was a good check. So in this case, what do we need to do first? We need to isolate the parentheses that the exponent is affecting. Now we have that isolated. So to get rid of the 1/2, we're going to raise it to the 2 over 1. And we do it to the other side also. 2 over 1 is the same thing as just squared. So we get 2 over 2, which is a value of 1, so we just get 1/3 x minus 11 equals 25. Add 11 to both sides. Now if you have a denominator, we're going to multiply that denominator to both sides to get 108. So now we know what the value of x is. And if we check this, you'll notice that when we plug 108 back in, when you divide 108 by 3, we get our 36. Subtract that by 11 to get 25 to the 1/2 power, which is 5. Then if we take 5 and subtract 3 from it, you're going to get a value of 2, and that's what we started with. Now we're going to look for even some more extraneous solutions. Raising each side of an equation to the same power may introduce extraneous solutions. When you use this procedure, you must check each apparent solution in the original equation. So still, you want to isolate your radical. You see that your radical is all by itself. You cannot add the 6. You cannot pull a 6 out of a radical. So we square both sides. When you square square root, you get what's inside. And on this side, you do not have x squared and 64. You've got to square the binomial, and that's going to give us x squared minus 8x minus 8x plus 64. Now we can add our 6 across. We can subtract an x. So we've got x squared. This is negative 9 and negative 8, which gives us negative 17. Positive 64 and positive 6, which gives us positive 70. So notice how this one has two different types of x's. So we know that this might be factorable. This has a leading coefficient of 1, so that we can just ask ourselves what multiplies to be 70 and adds to be negative 17. Well, we know that 2 and 35 makes 70. 3 doesn't go in there evenly. 4 might not go in there evenly. 5 might. But if you think about your numbers, you're going to get 7 and 10. That multiplies to be 70 and adds to be 17. We want it to be a negative 17, so these both have to be negative. They would multiply to be a positive. They would add to be a negative. We want this, because we cross everything out, we need this to be equal to 0. That's why we brought everything over to the same side. So now we're going to do our 0 product property again. So we have two answers. We've got to see which one is accurate and which one may not be. So let's check this guy. So we're going to say 7 minus 6 equals 7 minus 8. 1 equals negative 1, and that's not true. That does not equal each other. So I'm pretty sure that that's not true. This should be an extraneous solution. On this side, let's check that one. The square root of 10 minus 6 equals 10 minus 8, which is the square root of 4, and 2. So the square root of 4 is 2, so that one worked out just fine. So we circled the only answer that counted. The other one is called extraneous. We look at the next one. We notice that it has a square root and it's isolated. It's by itself already. So we're going to square both sides. So we have to write the binomial twice. When you square an equation, you get what's inside. Square square root, you get what's inside. You get x squared, you get negative 2 and negative 2, which is negative 4x. 2 and 2 is 4. Subtract the x. Subtract the 10. So we're left with x squared minus 5x minus 6. So how can you multiply to be a negative? The signs have to be different. And add to be a negative. The larger number has to be negative. So then we do our zero product property. And we'll go and check our answers. So we'll plug 6 minus 2 equals the square root of 6 plus 10. 4 equals the square root of 16. 4 equals 4. That worked out just fine. Negative 1 minus 2 equals negative 1 plus 10. Negative 3 equals the square root of 9. Negative 3 equals 3. No, that doesn't. So that is not a solution. It's called extraneous. So our only answer is x equals 6. Okay. Sometimes you might be dealing with something where you've got to square twice. When an equation contains two radicals, you may need to square each side twice in order to eliminate the radicals. You still want to get a radical by itself, and then you have to do all the math, and then that leads you still to have a radical, and you might have to do it again. Like a problem like this. If you have two radicals, you may need to slide one of those radicals to the other side. And then you would square both sides. So you got to do this side twice. That leaves us with x plus 5, 25, minus 5 square root of x, minus 5 square root of x, which is minus 10 square root of x, and a positive square root of x times the square root of x is x. So moving your values across would give you x minus the 25 would give you negative 20. Subtract the x to the other side. Let's see, minus 25 minus 25 minus x would eliminate that. Let's see, let's write it out like so. Then you would subtract your x. Don't forget your 10 in there. So we're going to divide by negative 10. And this will come out to be 2. So then you got to square both sides. And 4 equals x. And if you plug 4, the square root of 4 is 2. 4 plus 5 is 9. That square root is 3. So 2 and 3 is 5. It checked. So that's an example of needing to square twice.